Okay, welcome to your first video lesson of the year by Mr. Ducharme. Some things to know is I end up talking loud at some points, so you might have to turn the volume down. I do end up breathing heavy, so it's kind of annoying. I do make weird noises. Just ignore all of them. I'm trying to record them in a quiet place, but sometimes noises happen. I am going to talk kind of fast, so if you're noticing that you can't really keep up with me, just pause the video and wait for me to go. You can also fast forward a little bit and just copy all the notes down and then listen to me talk. At the end, I am going to do a bunch of examples in the blank space that I provided. So make sure that you're taking a second and going over the examples so that you're not completely confused on the homework. If you end up being a little more confused, make sure to email me and set up an appointment. So let's start this. So we're dealing with exponents, and what does that all mean? Well, by now we should know that an exponent means we're doing multiplication a certain number of times. So if you look at our examples that we're going to do in this first chart, they're all cubed, which means we're multiplying something by itself 3 times. In this case, it depends on the parentheses. So if you look at this first example, it's negative 3x cubed. Well, there are no parentheses, so I assume that the base, or I assume that the thing that is attached to the exponent is just x, because there's no parentheses, there's nothing around the negative 3, so the negative 3 is separate. Therefore, what this problem is actually asking me to do is it's asking me to take that negative 3 and multiply it by x 3 times. Now, if I actually did this problem, I should get what I originally had, which is negative 3x cubed. Pretty simple, pretty straightforward, but we gotta watch out for those parentheses because it changes what the answer is going to be sometimes. Now, the next one is the negative on the outside of the parentheses, but the 3x inside the parentheses cubed, which means the base, or the thing we're going to multiply 3 times, is this time is 3x. So what I'm actually doing is I'm multiplying a negative, which is secretly a negative 1, if we all remember, times 3x 3 times. 3x times 3x times 3x. So, and because I'm a math nerd, I'm going to kind of walk through what I'm thinking in my head. I know that 3 times 3 is 9. I know that 9 times 3 is 27. And then 27 times the negative 1, I always deal with the negatives last, is negative 27. It's going to go away for a second. And now I have 3 x's, so again I have x cubed. That answer is a lot different than our previous answer. Finally, this time the parentheses around everything. It's around negative 3x, making it the base, which means we are going to multiply negative 3x by itself 3 times. Now, if I do that in my head, negative 3 times negative 3 is a positive 9. Positive 9 times negative 3 is negative 27 again. And then I have that x cubed. Now, they're not always going to be the same, but in this case, because of the negative and the exponent combination, we got the same answer as the one before. But again, it's not always going to work out that way, so don't get too excited that it did. However, you notice that the first 2 answers are way different, or I'm sorry, the second 2 answers are way different than the first answer because of the parentheses. So just watch out for parentheses, watch out for negatives. That's a big part of this class that we got to watch out for those orderings. Okay, so now we're going to move on to some properties. Some of you have probably seen before. Algebra 2 is going to make a couple of them a little more complicated. So let's just go through what they mean, what they look like. We're going to do a number example, an algebra example, and so on. I'm going to make my font a little smaller. So the first one is the zero exponent property. And what that means is if you take a non-zero value, so anything but 0, raised to the power of 0, to the 0 power. Okay, so anything that's not 0 raised to the 0 power is equal to 1. I guess I don't need that comma for all you English people. You'll notice that I spell things wrong and I use excessive commas, so ignore my grammar because it's not very good. What that looks like in numbers is, I don't know, we can literally pick any number, like 70, and raise it to the power of 0, and it's going to be 1. We could do negative 6,298 and raise it to the power of 0, and it's still 1. Same goes with fractions. 1/2 to the power of 0 is 1, so on and so forth. So that means if we were going to turn this into a general property, that means anything, so we'll call anything a to the power of 0 is equal to 0. Next, we have this thing called the negative exponent property. And this one's a little wordier and tends to be a little more complicated. So again, a non-zero base. So that means we're raising something that's not 0 to a negative power. So raised to a negative power. Is equal to the reciprocal. Well, that's another math word. The reciprocal R-E. This is my spelling. C-I-P-R-O-C-A-L. I think I did it right. Of the base. Raised to the opposite. The opposite. I'm just going to write positive exponent because I'm running out of room. Whew. So that's a lot of words, and it might be a little confusing, and that's okay. What that means is if I had something like 7 to the negative 2, and you're looking at that like, whoa, 7 raised to the negative 2 power. That's the same as the reciprocal raised to the positive power, which would be 1 over 7 squared. So again, we just flip it, we put the base on the bottom, and then we change the exponent to positive. So we took it from 7 to the negative 2 to 1 over 7 squared. Now that's the same as saying 1 over 49 if we finish it off. Boom. Now you can also do this to fractions. Like if I said 1/2 to the negative 4th. Actually, don't write that down. 3/2 to the negative 4th. That's the same as saying 2/3, so again the reciprocal, to the positive 4th. So you flip it. We're not going to go through actually solving that one, but just so you know, just so you get used to the reciprocal. Once we take the reciprocal, we get rid of the negative. So if we were to write this with a variables, this first one would look something like a to the negative n is equal to 1 over a to the n, so we just flip it. This next one would be if I did a over b to the negative n. That's the same as saying b over a to the n. So again, we're just taking the reciprocal and making the exponent positive. So that one tends to be a little more complicated. If that's a little confusing, don't worry, we're going to do some examples at the end. So the next one is called the product of powers property. So now we're going to get into we're changing things from multiplication to addition, division to subtraction. Oh, there's my Snapchat noise. So product of powers property. So to multiply powers with the same base, base, you're going to add the exponents. And what that looks like is if I had 4 cubed times 4 squared, that's the same as saying 4 times 3 plus 2, or 4 to the 5th. In variables, that would be x to the n times x to the m is going to be equal to x times n plus m, or to the n plus m power. So again, when you're multiplying something with the same base, you add their exponents. Quotient is just the opposite, because quotient means division. To divide powers, with the same base, you subtract the exponents. Subtract the exponents. So what that looks like in numbers is if I have 3 to the 7th over 3 squared, that's the same as saying 3 to the 7 minus 2, which is 3 to the 5th. In variables, we'll just use a again. Anything to the m power over anything. Whoa. I did not even to the n power is going to be anything to the m minus n power. Now, I'm sorry, my a's kind of look like 2's, but those are a's. Next one, we have 3 left. Power of a power property. Ooh. To raise one power to another power. So to raise one power to another. To raise, yeah, I get annoying with repeating. 1 power to another. You actually end up multiplying the exponents. So what that looks like is if I have 6 squared to the 10th power, you're actually going to multiply the 2 and the 10 because it's a power to another power to get 6 to the 2 times 10, or 6 to the 20th power. Now that's a huge number, so I'm not really going to deal with it. If we were to write that in variables, that's, again, I'm going to get back to a to the m power to the n power is the same as saying a to the m times n. Now here's kind of the distributive property of exponents, but they call it the power of a product property. So if you apply an exponent to a product, or to find the power of a product, you are actually going to apply the exponent to both factors. Apply the exponent to each piece or factor. For example, if we do something like 3 times 4 squared. Now I know for many of you are just going to say that's 12 squared. I get it. We're also just I'm trying to show you the point here. That's the same as saying 3 squared times 4 squared. Now most of us in our math career would just do 12 squared, which is what I want you to do anyway. I'm just trying to show you an example of the property. What you're going to see more in your homework tonight is when you have like A, B, C all to a power. That's the same as saying A to the power, B to the power, and C to the power. Okay, you apply it to everything. And finally, the power of a quotient is very similar to power of a product. So if you say to find the power of a quotient or fraction of a quotient, Q-U-O-T-I-E-N-T, you're going to apply the exponent to each part, meaning the numerator and the denominator. I don't write those words out because they're too long. Numerator and denominator. So for example, if I have 3/5 squared, that's the same as saying 3 squared over 5 squared, which is 9 over 25. I didn't do that in most of them, but you will be simplifying your final answers. So if we had a variable, a over b to the m power, that's the same as saying a to the m over b to the m. Okay. Take a second, look it over. That was a lot of writing and information all at once. We are going to kind of move on from this and talk about scientific notation. Again, you might still be a little confused. You might want to wait until the examples at the end, which is fine. I get it. Just know that we're going to use all that free space for examples at the end. But before we do the examples, let's talk about some scientific notation. So I'm going to move over to my unused colors and talk about scientific notation. So if we're going to deal with two different kinds. We're going to see something like 1.756 times 10 to the fourth. Actually, I'm going to make this a little bigger because we don't need it that small. And on this side, we can see something like 1.756 times 10 to the negative fourth. Make that a little bigger for everybody so that they're the same size, because that would bug me if they're not. That's close enough. So, what does this mean? So we'll start with the positive exponent. On your calculator, you might see something like this if you got this as an answer. 1.756 E4. Okay? Now that's the same thing as saying what's on the top. However, do not write that on your test. Write the top. Know that E means times 10 to whatever the power is after the E. Do not write the E. It's going to be my pet peeve. So when you have times 10 to the fourth, a positive exponent moves the decimal to the right. And what I mean by that is if I have 1.756, I'm going to move that decimal place 1, 2, 3, 4 to the right. And everywhere I have a empty space, I fill it in with a 0. For my final answer to be 17,560. Now I'm just going to I'm going to cheat. Oops. I am totally going to cheat because I can. Don't write it exactly the same. So on your calculator for this one, you're going to see e to the negative 4, which means the negative 4 power, and a negative exponent. Hey, get off my screen. A negative exponent moves the decimal to the left. So if you see something like this, I'm going to write it over here this time. We're going to move that decimal place 4 to the left. 1, 2, 3, 4. Again, we have a bunch of blanks this time, so we have to fill them in with zeros for my final answer to be 0.00017556. Now, just like regular exponents, you can actually divide scientific notation. So what that would look like is if I came over here and did a little mini example. 4 times 10 to the 4th over 2 times 10 to the 6th. I would have to treat something like this separately. So I break it in half, and I'm going to look at the numbers first. Well, 4 and 2. 4 divided by 2 is 2. And then remember, when I divide things with the same base, I'm actually subtracting the exponent. So it's going to be 10 to the 4 minus 6. 2 times 10 to the negative 2. Now, when things are in scientific notation, you can leave your final answer with a negative exponent. That's fine. When I get into the examples, you're going to see that sometimes we're going to rewrite it without a negative exponent because that means it's more proper. So right now, I'm going to get into the examples before I write the homework down. If you think you got it down, you can skip to the end and just get the homework problems and try them on your own. But I do want to give you a couple examples before I unleash you. So I'm going to write examples. We're just going to do them in the blank space down here. So my first example is actually going to be something that we didn't really touch on because it actually comes up as a big mistake. And the reason I'm doing it is because it messes up. So if I had something like a times b plus b, sorry, not times, squared. This is not a squared plus b squared. This is a huge mistake that I see a lot. It is not a squared plus b squared. When you see something with addition or subtraction in it, that means you have to FOIL. And this is just a quick little example of how we FOIL. I am going to do it how I prefer. Now, some of you may have never seen the box before, but this is how I organize my work. So I'm going to erase this because it's actually technically the box. So if I do A, B, A, B. So when I multiply this out, A times A is A squared. A times B is AB. Again, A times B is AB. And B times B is B squared. And then we add everything together in the boxes. So I have A squared, plus AB plus AB plus B squared, which is the same as A squared plus 2AB plus B squared. Now, that is just, again, remember that that is not the same as A squared plus B squared, as you can see. That's a huge mistake that happens all the time, but it's okay. You haven't FOILed in a while. Let's just move on. That was a quick example of FOILing. Quick distribution example. And I don't want you to get this example confused with the property that we talked about when you distribute the exponent, because it's not. Have any questions on that, let me know. The next example. Let's do something like 3/4 to the negative 2. Okay, so we're always going to deal with the negative exponent first. So if we deal with the negative exponent, that means we have to take the reciprocal. So it's actually going to be 4 thirds squared. Once we do 4 thirds squared, we can actually do the problem and distribute it to the numerator and the denominator to get 4 squared over 3 squared, which is 16/9. So again, deal with the negative exponent first to get the reciprocal. Then we're going to actually multiply it out if it's just numbers. However, it's not always going to be just numbers. You could deal with things that are variables. And my example for variables, let's just make it really complicated, would be 2x squared y times 3x to the negative 4th y squared. So when you see something daunting like this that has a bunch of letters and some numbers, just treat everything separately. So I'm going to walk you through what I'm thinking. The first thing I'm going to think is I'm going to deal with the numbers, because I can do 2 times 3, and 2 times 3 is 6. Okay, the next thing I'm going to look at is, okay, the x's. I have x squared and x to the negative 4th. I know that if I'm multiplying two exponents together, I'm doing addition. So 2 plus negative 4 is negative 2. Finally, I have y to a secret 1. Remember that if there's no exponent, it's 1. And then y squared. So I have to add those to get y cubed. Now, this is not an acceptable final answer because it's not in scientific notation. So my acceptable final answer, I have to take that negative exponent and make it positive, and the only way to do that is do the reciprocal. So I end up with 6y cubed, because those are all positive, over x squared, and move it to the bottom, because that negative moves things to the opposite part. So if the negative was on the bottom, we'd move it to the top. Since the negative was on the top, we move it to the bottom. My last example is going to be a simplifying example. And I'm going to do 25xy squared over 5 x squared y. Now, how I do these problems is, again, I break it up. So if I think about it, I'm going to end up 25 divided by 5 is 5. So that I dealt with first. X over x squared. Now, that's subtraction because it's division of exponents. So I get 1, that secret 1 that's not written there, minus 2, which is x to the negative 1. And finally, I have y squared over y, so 2 minus 1 is just y. Remember that we don't want those negative exponents, stray marks. We don't want that negative exponent in our final answer, so we're going to move that x to the bottom to make the exponent positive, and I end up with 5y over x. Whew. So again, that was a lot of talking, that was a lot of information. If you have any questions, please email me. Please set up an appointment. We can maybe do a couple of the homework problems together. Speaking of which, your homework for this section is going to be at page 38. I believe it's 2 through 32 even, but you can check Schoology on that one. And then doing one of the story problems, which I believe I picked 37. Again, it's all in Schoology. If this is different than Schoology, please just do what's on Schoology. And this is due review day. So if you have any questions, bring them in for review day. Or bring them in if you want to make an appointment and really don't understand this section. Thanks for dealing with your first video unit, and look forward to going over this in class with you.